Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Azura Binti Halim. My metric number is DE200088. My PSM title is Design and Development of Multi-Channel Data Logger for Energy Measurement under the supervision of Dr. Rosa Binti Aziz. So for this video presentation, the presentation outline are as follows, which is the first part is the introduction containing background of study, problem statement, objectives, and scope of study. The second part is the literature review containing previous project, data logger, home energy measurement, and wireless communication. And the third part is the research methodology, and I'll be explaining for flowchart, hardware and software requirement, and coding development. And the next part is the result and discussion, where I'll be showing you the preliminary result and the coding details. And the last part is the conclusion, and I'll be explaining for conclusion and my recommendation for my future work. The first part of introduction is the background of study. An important property of electricity grid is that production must be carefully matched to consumption in order to keep voltage and frequency stable and avoid damaging expensive infrastructure. Customer activities, needs and desire, as well as weather, shape the patterns of electricity use, and this pattern typically result in high concentration of electricity use in peak periods. As the larger the peak demand, the greater the number of electrical resources that are needed to meet it. Hence, it is of fundamental importance to have a measuring tool of home power monitoring for electrical outlet to find out which outlet uses the most power than the other. And to measure energy consumption at the electrical outlet, a multi-channel electrical power measurement data logger is used. The socket is a place to install the appliances, considering that the point of the socket in the household will not change, and the socket itself is the outermost layer before electricity will be used by the load. Design and development of multi-channel wireless data logger for energy measurement is discussed that is capable of accurately measuring energy and related parameters like voltage, current, and power in real time, and equipped with a Bluetooth-based wireless communication module. Aims to obtain the electrical power measurement at an electrical outlet wirelessly to estimate the power usage as well as detect the highest reading, and alert the responsible user to reduce the energy utilization. There are three problem statements that are stated in this report, which are: the first one is higher power consumption in household sector electricity customer and the effort to save on their use. The second one is the tremendous amount of electricity resources needed as the energy demand rises. And the third one is the least sensitivity on the peak energy utilization to inform the owner of the household about excessive power consumption. Next is the objective of this project. The first one is to develop a prototype of a multi-channel wireless data logger for energy measurement. The second one is to analyze the values of voltage, current, and power obtained by the wireless and traditional multi-channel data logger. And the third one is to design a system that allows alert notification to be sent using the wireless connection. And the last part for introduction is the scope of study. The first scope is this project will focus on wireless monitoring the data logger for home energy measurement. The second one is the data that will be measured are voltage, current, and real power. The third one is the device is developed supporting Arduino Mega board with voltage and current sensor, a GSM module, and a Bluetooth module. The next one is the prototype ought to be ready to send alert notification to specific mobile number and monitor the power utilization at the electrical outlet. And the last one is the price of components used to develop should be reasonable and affordable. For literature review, the first part is the previous project, where I refer from the previous project that has been done, that they used to build a home power monitoring system. And the first one is by Firdaus Jonathan and Tri Wahyu Octaviana Putri on the year of 2021 with the title of Prototype of Home Power Monitoring Tool for Electrical Outlet using ESP32. The second one is by Kumarisan P. Prabhukumar and M. Bharat Kumar E. by the year 2020 with the title Smart Home Energy Measurement and Analysis. The third one is by Mat Rokonozaman, Mat Imran Hussein, Muhammad Katun Mishu, Muhammad Shakuri, Mat Raishul Islam and Noshad Amin in the year of 2021 by the title of Design and Implementation of an IoT-enabled smart plug socket for home energy management. And the last one is D. Sindanai Selvi, S. Kartika and T. Shanmuganatham is the writer. It is written on 2018 by the title of Energy Efficient Modern Home Using Smart Board for IoT Energy Automation. Next, I also refer to some articles about data logger to know more about the meaning of a data logger. The following here is the articles that I used to refer. So, what is data logger? Data logger is required to collect data from sensors and save it to data storage. A data logger is used in variety fields, including astronomy, industry, and medicine. And one of the articles that I refer here also stated that a data logger can be a single unit, standalone device with internal sensor that fits in the palm of your hand, or a multi-channel data collection instrument with one or more external sensors. So for home energy measurement, I did refer to 3 articles which are right here. The first one here for allowable loads energy consumption, and the second one right here is for the criteria of an effective home energy measurement, and the last one here is for impact of a proper home energy management. So for the first article, I do research about allowable loads energy consumption, and it shows the energy efficiency sticker for every loads in Malaysia. And for example, the highest home load is the aircon. The allowable energy consumption for 1 year is 932 kilowatt hour. And for the second article is for a criteria of an effective home energy measurement. The article states that the system must be a learning tool, not just a monitoring tool, and then it should be tailored to individual user and should reduce the user effort in dealing with the system. And then for the third article right here is for impact of a proper home energy management. It shows the statistic proof that a home energy management system can reduce the electricity bills. For example, energy consumption saving feedback appear to range between 5% to 20%. Home energy management system saving potential has been estimated. So for wireless communication, in this project we use 2 types of wireless communication, which is GSM and Bluetooth. So for the article I refer here is 2 articles above here is for GSM and the 2 below here is for Bluetooth. What is GSM? GSM is Global System for Mobile Communication, and I'm sure for Bluetooth everyone already exposed what is the meaning of the Bluetooth. Tada! We're back again for the third part of the presentation today, which is the research methodology. First, I'll be scanning for the project flow chart, and I'll be starting from the review the journal and books to find additional information right here. And then I will start develop the prototype of the multi-channel wireless data logger for energy measurement. And I'll be in the section of coding development using Arduino software, and I'll be designing the circuit of the data logger system. And then I'll be assembling all the components right here according to the circuit that has been designed up here, and then I'll be compiling the coding developed from here with the assembled component. And the first diamond question is, do the sensor identify voltage and current? And after this question, if no, the prototype is not detecting any voltage or current, I will go back to the designing of the circuit to ensure that the design circuit is alright or not. And then if yes, if the prototype detecting voltage and current, it will start to analyze the sensor reading such as voltage and current and power. After that, it will go to the next diamond question, which is, does the power consumption measurement read exceeding the value of 2.55 kilowatt hour? What is 2.55 kilowatt hour? It is from our literature review, which is the most allowable energy consumption for home is, for example, aircon for 932 kilowatt hour for 1 year, and then we divided 132 kilowatt to 365 days to get 1 day's kilowatt hour reading. And if the question is no, it will end the system, and if the question is yes, then the GSM based system will send notification using wireless connection with existing data logger system. The next one is a system flow chart. So the flow of my system of this prototype of multi-channel data logger for energy measurement will start with the sensor detecting voltage, current and power of the loads, and Bluetooth based system will start to operate, and the LCD will display voltage, current and power. After that, if the energy consumption is greater than the limit which I mentioned before, 2.55 kilowatt hour for 1 day, if it exceeds the limit, it will go here. The LCD will display energy consumption exceed your limit, and it will delay for 1 second and send alert notification command, which the GSM-based system will start operate by sending notification to the user. After that, it will start new iteration. Okay, next for hardware requirement, we need 6 hardware, which is the most important is the microcontroller Arduino Mega, and then we need ACS712 current sensor, and then we need ZMPT101B voltage sensor, LCD display, GSM module, and Bluetooth module. And the important software requirement are Arduino IDE, Projek for designing, Arduino IDE for recording, development, and compiling, and for freezing also for circuit design, but freezing cannot simulate, but Projek can simulate. That's the difference between circuit designing in Projek and in freezing. So welcome to Arduino IDE dashboard. So as you can see right here is the void setup. Void setup is where we put the setup code here to run only once. But for void loop, we put our main code here to run it repeatedly. Everything that we declare outside of the void setup and void loop is called as global variable, where the variable can be used in every void, every function that has been created. But if the variable is inside this function, so the variable cannot be used for another function, which means it can be only used inside the function. For example, if the variable is stated inside void setup, so it will be used in void setup only. I'll be explaining to you for the coding of the LCD interface. So the first line here is that we include the library code, and then this one constant integer right here, RS, EN, D4, D5, D6, D7 is the pin that we connect between the LCD and the Arduino. And then this is the liquid crystal LCD variable calling. And this is void setup, where we put the LCD begin 16.2, which means the column and the row of the LCD. And then we command the Arduino to LCD pin hello world, and this will be displayed on the LCD as shown in the report. And then for void loop, as you can see, the LCD set cursor 01 as the LCD number and column is 16 and 2, so the LCD set cursor need to be at the upper left of the LCD 01. And then this is the LCD print list 1000, which means the LCD will print the number of seconds since the reset of the coding. I cannot demo the LCD display because my LCD is already broken. So as you can see, what does the LCD display is I already put a picture inside the report. So next I will explain about the coding development for voltage sensor. So as you can see, all of the variables stated here is the global variable where it will be used inside of the void or the function that created down here. And then this is the void setup serial begin, where we will use the serial monitor to display the reading of the voltage. And then inside the void loop, we put the condition for the voltage sensor pin reading, and we also put a formula to get the correct value. Instead of getting the digital value, we will get the RMS value, the analog value. And then the serial print or the serial monitor will print voltage equal to the value of the voltage after calculation. And this is the delay for 1 second. And the last one, I'll be explaining the coding for current sensor. So here we define the current sensor pin AO as the global variable, and then we define here the variable I we use for current. And inside void setup, we serial begin, where we will use the serial monitor, and then here is the pin mode, where we declare that the current sensor pin is as an input pin. And inside the void loop, we declare the analog read of the current sensor as the I, and the serial print will print I and show the value of the current sensor. And we delay for 1 second.
Circuit diagram. Components needed. Circuit diagram. Components needed. Serial monitor display. Circuit diagram. Components needed. Serial monitor display.
The last part of the presentation today is chapter 5, which is conclusion and recommendation for future work. For conclusion, in conclusion, the project's problem statement, objectives and scope written in chapter 1 were reviewed both by panel and supervisor. On top of that, the useful and additional information related to the project, such as energy consumption limit for loads, was discussed during chapter 2. The component interface that has been done during PSM1 are ACS712 current sensor, ZMPT101B voltage sensor, and liquid crystal display LCD. Furthermore, the important coding syntax for 3 components has been studied. And last but not least, the software requirement for current and future use has been listed in chapter 3, which is research methodology. For our recommendation for future work, I plan to interface GSM and Bluetooth module during PSM2, and I also will combine all the coding, each of the component, to form the system of the data logger. And lastly, I will do the analysis of between the measure value by the sensor and also the measure value by the instrument that I will do during PSM2 next semester.